G'day, year 10s. I'm just going to give you a video now about how to translate graphs up and down, vertically and horizontally. We're going to do vertical first. It's pretty straightforward. This is the extract from 18D in your textbook, and the algebra that goes with moving a graph up and down is this little bit here, y is equal to f of x plus k. So let's just think about our initial graph here. What they're telling us in this picture is y is equal to f of x. That's our original. They want to move it up k units. So we go y is equal to f of x plus k, and the plus k is outside the brackets. It's not part of changing the function. We just need to change it. We just need to add something in on the to the very end. So let's make sure we get the language right. Y is equal to f of x plus k translates the graph of y of f of x vertically k units. If k is positive, greater than 0, it moves up. If k is negative or less than 0, it moves down. So in this situation, we've got the light blue line there. That's our original. They've added a value of k. It goes up. If we added a negative value, or really you should think about taking away a value, you'd end up with a line down here. That would be a negative f of x minus k. So let me show you an example. Now what I do have is a quadratic. This is, I'll tell you what it is. This is the function f of x is equal to x squared minus 5x plus 4. This is going to be our original function, and we will move this upwards to start with. So we'll do a quick up, we'll do a quick down, and then we'll be done. So let me give myself something to work at. So we're going to come back on Desmos in a minute and check that this is all correct. So let's just write this down for us ourselves. Give ourselves some working out space. So I'll do the original in blue, and we'll do the new thing in we'll do the new one in a different color. So for drawing graphs, we know y is equal to f of x, and we need to define that function. So I'm going to do that in black for myself. F of x is equal to x squared. Oh, that's not a good x, minus 5x plus 4. Now, just a little note here while we're doing it. At the moment, this is in the format y is equal to ax squared plus bx plus c. This, if a doesn't equal 0, this gives us a quadratic. That's just a little side note, because when we do some algebra in a minute, we want to put it back into this format. So I'm just going to keep that up the back there. Now, this is our original function. The function of x is equal to x squared minus 5x plus 4. What that means is you put some number in here for x that lines up with the x-axis, and you follow this rule, and that will line up with the y-axis, because y equals f of x. Now, I'm just going to erase our x's for a second. Do our x's in blue so that it's really obvious where they came from. So we've got f of x equal to x squared minus 5x plus 4. Okay, so let's do the new one. We want to move this. Let's move this up 4 units. So to translate, make sure we get the language correct. To translate vertically up 2 units, the new graph y must be equal to the old graph f of x plus 2. Okay. Oh, I just realized I didn't need to do this because I'm not changing anything on the x-axis. Anyway, we'll leave that like that. That's okay for now. No, I will change it. I will change it. I'll make this all black. Okay, so put that back in black. x squared minus 5x plus 4. Okay, so let's do a new one. So f of x plus 2 must equal whatever f of x used to be. Let's fix that little to the power of 2 and plus 2 on the end. So our new one must be x squared, because that's the same, minus 5x. We just need to think about what this turns into here. I'll just highlight what we're going to change. These two are common terms, plus 2, plus 4, and we've got plus 6. X squared minus 5x plus 6 should be 2 units higher than x squared minus 5x plus 4. So let's go and have a look at our, this is our function here, x squared minus 5x plus 4. Let's go back to Desmos. Let's put it in where it belongs. And what should we do here? Let's go plus 6. And let's go, oops. Sorry about that little section there. Okay. Right. So we've got our original function, f of x equal to x squared minus 5x plus 4. We've got, I might change this to g of x actually, because it is a different function. G of x equal to x squared minus 5x plus 6. Now what we're trying to establish is whether the green one is exactly 2 units higher than the blue one. And the easiest way to do that is find our turning point of the blue one, the first one, 2.5 and negative 2.25. I've obviously organized this earlier. 5 over 2 bracket, comma, negative 9 over 4 is 2.5. Negative 2.25 is the turning point. Now, if the turning point of the green one is exactly 2 units higher, just here, and it is, well, let's put a negative in there. That will work. So we can label this point here 2.5, negative 1/4, and that is exactly 2 units higher than the first one. So that worked. And that's how to translate up. So vertically, 2 units in the positive direction. We'll just quickly go back to the whiteboard very quickly. And that correctly translates it 2 units up. I'll do another one for you really quickly. And if I wanted to go down, just as an example, I could say, oops, back. Let's do that a bit in black, so it's really obvious. F of x, if I wanted to go down some number of units, I could go -3. And x squared is the original, minus 5x plus 4 is all part of the original, function. The -3 is new, it's at the end of the function, and we can get a new function for ourselves, x squared minus 5x. If we combine these 2 bits of information here, plus 4 and -3, that gives us a positive 1. And that would be a vertical translation. 3 units down. Now, when you describe this, please make sure you hit the words vertical translation and how many units up or down. That's the appropriate way to do that. And as you can see, I've got this in x squared minus 5x plus 1, which is in this format: ax squared plus some number of x squareds plus some number of x's plus some number at the end. The only one that can't be 0 is the a, and that's what I've done. I've got that on there. That one's correct. That will go 3 units down, and this one here, which we've already checked is correct on our graph is 2 units up. And that's how to vertically translate functions.